So when I made up this video series on colligative properties, I was really seriously debating if I even want to make videos on colligative properties, because a lot of this really just kind of plugging and chugging into formulas. There's not a lot of concepts behind it. So on the one hand, I recognize you need videos. On the other hand, I think this is pretty easy material. So let's compromise. What we're going to do for the colligative property videos is that I'm going to show you the formulas and explain conceptually what's going on, but I'm not going to work any examples. Those you kind of need to do on your own. But you've got these videos to kind of guide you through the process. So first colligative property we're going to talk about are boiling point and freezing point changes when you mix something in. And there's a very simple formula for this. Delta T equals K times I times little m. So delta T equals chem. What are our terms in this equation? Delta T is going to be the change in boiling or freezing. Now our change in boiling is always a positive increase, meaning that if we have water and we add something to it, the boiling point will only increase as we add stuff to it. So we can only go up. When we have a freezing point, our delta T is always negative, meaning that our freezing temperatures will always go down. Reason we do this is that basically what's going on is these molecules in solution are interfering. Particularly this is evident when you look at freezing points. For you to freeze something, you have to form a perfect crystal. And either you have to create imperfect crystals with your solutes still being in the crystal of the solid, or basically you have to use temperature to separate out the salts. Either way, you're going to lower the boiling, you're going to lower the freezing temperature. Boiling point's a bit more difficult to understand, but basically what happens is that because the molecules are dissolved in solution, they have affinity for a solution, you're increasing the IMF in solution. So it's not that you've increased the interactions between the solvent and solvent molecules, you've increased the interactions between the solvents and the solutes, and those solutes simply aren't letting the solvent molecules escape. Now our M is going to be molality. So this is something typically when you're given these problems, the hardest part, honestly, is calculating molality. I'll give you a mass, I'll give you a mass of solute, mass of solvent, and ask you to find molality long before you can even start doing this calculation. But really, go to the videos on molalities and concentrations. It'll walk you through how to do that. I is going to be our Hoff factor. Now, these are tabulated values. These are something you can't guesstimate or know. It's something you just have to look up. And you have to look at the homework problems or specifics on what type of Hoff factors to work with. Particularly though, if I don't give you a Hoff factor, just assume it's 1. On test though, you will see the Hoff factor, and there is a video on what the Hoff factor actually represents. Last term here is our coefficient for the solvents. Now you'll either see this as a KF or KB. KF is going to be referring to changes in freezing temperatures. B is going to be referring to boiling temperatures. These are solvent specific, they are not solute specific. So it only matters what your solvent is, it doesn't matter what you're dissolving into it. So to answer these types of questions, what's the change in temperature at the boiling point and the freezing point? You're going to look up your KF in a table. It's either KF or KB in a table, it depends on whether you're looking at freezing or boiling point, and typically on tests you're given these, otherwise you gotta go look in your book. Hoff factor, just go look it up in a table, and molality is typically something you're going to have to calculate.